since right now you have learned the concept of Atwood machine, now you are going to apply that concept of Atwood machine to understand the lift problem. Consider a person standing in a lift and its weight is acting downward. Weight will always act downward because weight is a force of reaction by virtue of the action of the Earth's gravitational attraction. The weight is acting downward. The normal reaction is acting upward. Now, students, since the lift is going up, which is dominating the reaction, which is acting up, R minus mg equal to ma. R equal to m into a plus g. What you learn, the normal reaction increases as the lift is accelerated up. As the lift is moving with more and more acceleration, the person will experience more and more normal reaction. The normal reaction, if increases, the person will experience increase in his weight. If you place a weighing machine and the person is standing on the weighing machine, the person will register increase in his weight as the lift is accelerated up. Actually, the weight of the person is increasing, but apparently. Apparent means temporarily. If the lift stops, the increase in weight will be 0 and the person will acquire his original weight. If the lift is even moving with the uniform velocity, then this acceleration is 0. Even then there will be no increase in weight. Now, when the lift is coming down, the scene is almost different than the up. The lift, as it is coming down, now the normal reaction is R dash. Now weight is dominating R dash. Then mg minus R dash is equal to ma. Assume same acceleration, a, magnitudes of the acceleration is same, that is a. So R dash equal to mg minus ma. If we take m common, it is g minus a. So R dash is equal to m into g minus a. It means there will be a decrease in the weight of the person if the person is observing his weight while standing in a lift. As you are coming down in a mall lift and the lift is accelerated down, you experience some decrease in your weight temporarily. Why? Because the lift is accelerating down and the normal reaction decreases. And students, if A is equal to G, then what happens? The lift will be falling in the state of free fall, means with an acceleration due to gravity G. Then the normal reaction R dash is 0. Hence the person will be in the state of weightlessness. There is one famous question: a person jumps from a building carrying a weight of 70 kilogram on his back. Will he be experiencing some weight on his back? Answer is no, because the person is falling freely under the influence of gravity. As a result, the normal reaction on the person is 0. Hence the person is in the state of weightlessness.
Your today's question is: like charge bodies, option A, always attract, B, always repel, C, may attract, or D, do not interact. To send your answer, just type LCB space your name space your right option space your class space your age and send to 9814121996.
Horse and cart problem. This is one of the most important concept of mechanics, exclusively for 10+1 students. This concept helps us to determine the movement of the horse and cart on a horizontal track. Means this concept, what we are discussing on your television monitor, is for horizontal movement of the horse and the cart. See, this is a cart, its mass is m. This is a horse, h, its mass is m. Now mg is the weight of the cart and small mg is the weight of the horse. Now mg is balanced by n2, the normal reaction, and capital Mg is balanced by n1, the normal reaction. Since the motion is horizontal, reaction is vertical, horizontal and vertical, they are independent of each other, so they can never be used to balance. So horizontal motion will not be affected by the vertical component n1 as well as n2. Now when the horse makes an action on the road by tilting its feet, by applying a force F which makes an angle theta, then the normal reaction R of the force F can be resolved into two components. One is R cos theta and the other is R sin theta. Right now I have told R sin theta is now joining n2, it will not affect the motion, horizontal motion, because it is vertical component. Therefore only R cos theta will be used up to make the system to move horizontally. So when horse pulls the cart with R cos theta, tension develops in the string which is tying the cart. So R cos theta minus T produces an acceleration A in the system. A is the horizontal acceleration which is produced due to the R cos theta. Now tension will make the cart to move with the same acceleration, but there is a force of friction between the cart as well as the track, say horizontal road. Therefore tension minus the force of friction is equal to MA. Now if we join the two, you'll get R cos theta minus force of friction M plus M into A. So A equal to R cos theta minus F upon M plus M. So students, this concept explains how a big mighty train can be pulled by a small engine. The engine has to apply only R cos theta. That's it. No matter whatever be the weight loaded on the track, on the train, but only R cos theta will produce an acceleration in the engine, produced by the engine in the train. Similarly, you might have seen some people are pulling aircraft or trucks by tying rope with their body or with their hair or with the teeth. The only concept is that they have to simply apply the effort R cos theta. The weight is not playing any role. Weight is balanced by the normal reaction provided by the earth. They have to simply work against the force of friction and they have to develop R cos theta.
Hope you enjoyed Vipin sir's lecture. Now your quiz question is, your today's question is, like charged bodies, option A, always attract, B, always repel, C, may attract, or D, do not interact. To send your answer, just type LCB space your name space your right option space your class space your age and send to 9814121996. Remember friends, you have to send your answer till next Saturday 5 p.m. Now it's time to go. See you in the next episode. Same channel, same time.